let's solve logarithmic equations with the same base. So this is dealing with our one-to-one property of logarithms. That states if the log of m base b equals the log of n base b, then m equals n. And that should make sense, because think about it. If this part is identical, then these should also be identical, right? So m should equal n. All right, let's do a couple. We're going to solve all of these for x, and we're going to do 5. They all should be pretty quick, so we'll see. But first here, log of x base 8 equals the log of 3 base 8. Well, these are the same base, therefore the arguments must be the same, so x equals 3. Let's do one a little more difficult. The log of 5x plus 2 base 7 equals the log of 27 base 7. These are both base 7. Okay, so if the log is base 7 on both sides, then the arguments must be equal. So 5x plus 2 must equal 27. Okay, let's solve this equation. I need to isolate x. So my first step there is to get rid of the 2. 2 minus 2 is 0. I'm left with 5x. So 27 minus 2 is 25. Last step is to divide by 5. So x equals 5. Now, with these, you have to make sure that the argument is positive, right? Which it should be. This should not be an issue. And therefore, if I plug in 5 here, I get 27. Log of 27 equals log of 27. That's good. Okay, and now I have the log of 2x plus 4 base 3 equals the log of x plus 8 base 3. Both base 3 arguments must be the same. So 2x plus 4 must equal x plus 8. Okay. Well, I have to isolate the x's. Let's get them all to the same side. I like to work with positive numbers as much as possible. So if I subtract x, right, 1x, if there's no coefficient, it's automatically a 1. I'm still left with 8 on the right. And 2x minus 1x is 1x. I still have plus 4. To get x by itself, I will subtract 4 from both sides. So x equals 4. If I plug 4 back in, 4 plus 8 is 12. 2 times 4 plus 4 is 8 plus 4. That's 12. That works. The log of 3x squared base 9 equals the log of 48 base 9. Again, same base. Argument must be equal. 3x squared equals 48. First step in isolating the variable is to divide by 3. So x squared equals 16. Well, to unsquare something, we will take the square root. And the square root of 16 is plus or minus 4, because 4 squared is 16 and negative 4 squared is 16. So this one has two answers, because if I plug in either one of those for x, because I'm squaring them, they both would give me a positive 16. And the last one, the log of the square root of x base 4 equals log of 3 base 4. Again, the bases are the same, so we know that the square root of x must equal 3. Well, how do you unsquare root something? Well, the opposite of that is to square it. So we square both sides. The square and the square root undo each other. So x equals 9. And that makes sense because the square root of 9 equals 3. So that's some examples of solving logarithmic equations with the same base.